Hi class, it's Mr. Trez, and this video is going to be about factoring quadratic trinomials when a is equal to 1. Our learning objective: the student will be able to factor quadratic trinomials when a is equal to 1. The objective will be met if the student receives a 100% on their Google Drawings assignment. Our essential question: describe how to factor quadratic trinomials when a is equal to 1. So just some key terms as a review for quadratic equations. Ax squared plus bx plus c is the standard form of a quadratic equation. Ax squared is referred to as our quadratic term. Bx is our linear term, and c is our constant. To factor trinomials in the form of ax squared plus bx plus c, we must find two integers, m and p, with a sum of b and a product of c. Then write ax squared plus bx plus c as x plus m times x plus p. So essentially what we're looking for are two integers, two factors. When we multiply them equals c, and when we add them equals b. So let's take a look at four examples. Okay, so our first example is going to look like this. X squared plus 9x plus 20. So what we want to do is really look closely at our quadratic equation. So when c is positive, its factors have the same signs. Both factors are positive or negative based upon the sign of b. If b is positive, the factors are positive. So in this example, we could see our c term, our constant, is positive 20. That means our factors are going to have the same sign depending on the b term. Okay, and the b term is positive 9, so we're going to have positive signs. So one way to solve is by using an area model. Another way is just to set up a chart. So we can have factors of 20, and then we have the sum of the factors. So let's get, since b is positive and c is positive, we want positive factors. So 1 and 20 is one pair, and that equals a sum of 21. Okay, we can also have 2 times 10, and the sum would be 12. And then finally 4 times 5, and that gives us a sum of 9. So this is the pair of factors that we want, because 4 times 5 is 20, our c term, and 4 plus 5 is 9, our b term. So the way we would write that in factored form is x plus 4 times x plus 5. Okay, so our key takeaway in this example is when c is positive, the factors have the same signs. Both factors are positive or negative based on the sign of b. So since b is positive 9, that means our factors are going to be positive. Okay, so let's take a look at our next example, which would be x squared minus 8x plus 12. So as we can see, c is positive, which means it's going to have the same signs. So c is positive 12. Our constant is positive. But now in this case, b is negative. So that means the factors are going to be negative. So we want negative 8. Okay, so we have our b term is negative 8, which means our factors are going to both be negative. So let's set up a chart. And we're going to write factors of positive 12, and then the sum of the factors. So now, here's the key. Since our b term is negative, our factors have to be negative. And we know that a negative times a negative is a positive, okay? So that's how we can get our positive 12. So one of the pairs could be negative 1 and negative 12. That gives us a sum of negative 13. Next we have is negative 2 and negative 6, and negative 2 times negative 6 is positive 12. And if we take the sum of the factors, it equals negative 8. So as we can see, there's our correct answer. But even if we just want to fill out the table, okay, negative 3 and negative 4, and that sum is negative 7. This is the one that we want right here. So to write it in factored form would be x minus 2 times x minus 6. Okay, so our takeaway in this example, when c is positive, the factors have the same sign. If b is negative, the factors have to be negative. So here we have our constant term is positive, our b term is negative, so that means our factors are all going to be negative. Okay, so now let's take a look at two examples. What would happen when c isn't positive? C is going to be negative. And so our first example, x squared plus 2x minus 15. So let's set up our chart. Factors of negative 15, and then we have the sum of the factors. Okay, so now let's take a look at our rules here. So when c is negative, the factors are going to have opposite signs. So to determine which factor is positive or negative, we have to look at the sign of b. So in this case, b is positive. The factor with the greater absolute value is going to have the same sign as b. So let's work through our table. Now we want two factors that equal negative 15. So one of them we can have is negative 1 and positive 15. So I'm choosing this because the absolute value of the positive, which is positive 15, is greater than the absolute value of the negative. Okay, and the negative is negative 1. And the reason why we want more positives than negatives is because when we add them, our b term has to be a positive. So the sum of the factors would be positive 14. Okay, the next pair would be negative 3 and positive 5, and that would give us a sum of the factors of positive 2. Okay, so if I did something wrong, if I put, let's say, positive 3 and negative 5, well, the sum of those factors would be negative 2. I don't want any negatives in this example because my b term, when I add them, has to be a positive. So these are really the only two pairs of factors that would work. This is the one that's correct, and the way that I would write it in factored form would be x minus 3 times x plus 5. Okay, so our quick key takeaways. When c is negative, the factors have opposite signs. We have a negative and a positive. To determine which factor is positive or negative, we have to look at the sign of b. And the factor with the greater absolute value is the sign of b. So in this case, we want more positives than we do negatives when we choose our factor. Okay, and our last example is going to be one that looks like this. So we have x squared minus x minus 20. So right off the bat, the b term of minus x does not have a coefficient. So the invisible number there is 1, so I'm going to put a 1 in. Let's make our table. Factors of negative 20 and the sum of the factors. Okay, so now here our c is negative. That means our factors are going to have opposite signs. We have to look at the sign of b, which in this case is negative. So the factor with the greater absolute value has the same sign of b. So now in this case, we want our factors to have more negatives than positives. So what are some factors of negative 20? So first one I'm going to choose is 1 and negative 20. And see how I have more negatives than I do positives? That's because when I add them, it's going to give me a negative answer for b. So this sum of the factors would be negative 19. Okay, so the next pair would be, let's say, 2 and negative 10. The sum of those would be negative 8. And then finally 4 and negative 5, which gives me the sum of negative 1. And this is the one that I want because negative 1 is my b term. So in order to write that in factored form, we'd have x plus 4 times x minus 5. Finally, our key takeaways here. C is negative. To determine which factor is positive or negative, we have to look at the sign of b, and in this case it's negative. So we want the greater absolute value to have a sign that is negative. We want more negatives than positives. Okay, we found our factors, and we write our final answer. If you have any questions, please send me an email, and thank you for watching this video.